changed and made new and become very much more exciting. Because you are no longer going to solve these equations, well, unless they tell you. You are no longer solving them by inspection, which means just by looking at them. You are now using the fundamental rules of equations. The book calls it the properties of equality to solve, which really means nothing. The props of equality. And in our racially whatever times, it's always good to be equality. That doesn't even make sense. Properties of equality, but I'm going to leave it there just so you can remember this. Now, here is what you have to remember. This is so simple, but people struggle with this. Okay? The basic gist of this property of equalities says this. This sums it up. I'm doing you a favor here because the book goes through all sorts of goofy whatever. Okay, you ready?
Yes.
Oh boy, I don't know how to say it. You can use any, well, let's do this. You can add, dash, subtract, dash, multiply, dash, divide, which are the four mathematical operations. Both sides of an equation by the same number and still get a true equation. There have been classes before when I gave that statement there, they literally could not take any more because they were so overwhelmed by it. I should just stop right there and let you just internalize that. Should I get my balance out? No, that's not.
Yeah, let's do it.
I'm going to draw one, mostly because it's a cheap one and it really doesn't hurt very well. And it doesn't really prove its point. But I could do it just for a visual. Here's the deal. What you are considering here, children, is this. Do I have pennies? Anybody?
I think you have pennies.
What happened to the pennies? Did you guys give me the pennies
I
back?
see them on that metal cap. Oh yeah, they're by the door.
Oh, there they are. This is what you must think about. Notice how that looks so balanced.
So balanced. Yum. Yum.
I'm going to try to wait. Pretend you don't see this because this is not part of the whole show.
Everybody close your eyes. What?
What's the deal with this?
Hello?
Wait.
Maybe
The yellow
oh,
things.
look, the thing's not in
It's
all
not
the
That
way.
makes no difference on how much it weighs.
The bottom is
Yeah, the bottom, the very bottom. One has air in it.
Aaron, who?
What?
Like that doesn't seem to help.
Had one.
The bottom's not in on it.
Yeah, the bottom is
Like-
not in. It's
Oh, no wonder it's not. Somebody should have said that to me.
the weights are in different spots. Yeah, you have to.
But they're not, but the weights are in the spot so that this side is as light as it can be and that side is as heavy as it can be, and that's not changing it enough. Let me throw some paper in here to get this. Better?
A little bit.
Moving a little bit.
Slowly.
There. Okay, so what that little statement says there is this. If you have this, you have to think about, whenever you think of equations, you should think about a balance. Equal means two things are equal. One side balances with the other side. They are the same. what that says is this, okay? It's called the properties of equality or whatever it is. If you add 2 to one side and add 2 to the other side, the thing will still be balanced. Just like your equation will still be true. Or, if you divide by 2, which if I took 2 and divided it by 2, I'd get 1 penny left on that side. And I divided this side by 2, I would still get something that's balanced when it straightens out. That's the whole gist of all that. And you can do that with subtracting. Look, I can subtract 1 from one side. As long as I subtract 1 from the other side, it's all balanced. There's your visual for today. The basic gist of this boils down to this. What you do to one side of an equation comma, you must do to the other. Exclamation point, exclamation point, exclamation point. Now, with that being said, I'll let you write that down and do this over here. So here's our equation. Let's just start with something simple. X plus 6 equals 12. I know you know the answer. That is not the point of any of this. When you come up with the equations now, first thing is you have to write them down. You'll write this on your paper. Now before, they said to just solve these by inspection, which means you just look at it and go, well, what number when you add 6 to it gives you 12? You would say, my answer is 6. Now you're going to use these properties of equality to solve this, and you're going to do that like this. The book will tell you to do this, and maybe other people in math will tell you this. You want to isolate the variable, which means you just want to get x by itself. You want to know what x equals. See how x is by itself here? It's gone. I want to know what x equals. Isolate it. Because if I know what x equals, I know my answer. Well, unfortunately, to get x by itself, I've got to get rid of this guy. I got to get rid of a 6. To which, the second step, after you do this thing here, isolate the variable, and you isolate the variable by what the book calls inverse operations. And I'm only giving you the little jargon just because you should probably know it. How do you spell operation? Inverse operation just means do the opposite. Do the opposite, which means, children, if this is an adding equation, you are just going to think the opposite of adding, which is subtracting. The opposite of adding a 6 is subtracting a 6. Because what happens if I have a 6 and I take a 6 away? What am I left with? Just this letter x, which is what I want, because I want it isolated. But if I take 6 away from this side over here, wait, here's my visual. I don't know what I'm doing. This. I'll take these pennies all weigh the same. But here's my equation that says. Here's my equation. Wait, no, maybe my podium is not good. Here's my equation. Right, let's pretend that this is equal. If I, like I did right there, if I take 6, 2, 3, 4, 5, 6 things out of this side, what's going to happen to the equation? It's not balanced anymore because this side is lighter. It's going to fly up in the air until I do what?
And take away 6.
I have to take 6 away from this side. And lo and behold, by the magic of me holding it there, it becomes balanced again.
What?
So, when I got to this point here, after I took 6 away from this side, I crossed that off. But in order to keep it balanced, I have to take 6 away from that side, which means x is going to equal isolated 6. And it's the same, that same thing no matter what what the equation is. I'm sorry, did I move that on you? If you have x minus 8 equals 15, to solve that equation, you think of the inverse operation, which is the opposite of subtracting 8. What's the opposite of subtracting 8? Adding 8, because when I have a minus 8 and a plus 8, they go away to leave me just the x. But I can't just leave it like that, because when I do, this whole equation becomes unbalanced. This is now 8 heavier than the other side, because I added 8 to it. I have to add 8 to this side, and I get 23. No longer should you have to think about what number when I subtract 8 from it gives me 15, because you just do the inverse operations all the time. Same thing is true for multiplication. 15x equals 90. This is 15 times x, by the way. The opposite of timesing, oh, Caleb just about fell asleep there. Just about. Opposite of multiplication is, and this is how you show dividing. You just go 15 divided by 15 is 1. And what happens? We don't put a 1 in front of x, we just put the x there. But if I divide this side by 15, now it's all out of whack because this side is 15 times heavier. So I have to divide this by 15, and everybody knows 90 divided by 15 is 6. And probably the hardest one for you to get at is this one, which is m over 15 equals 30. Anybody that's thinking the answer to that is 2 is incorrect. How do I get rid of a dividing by 15? No, opposite of division is multiply both sides by 15. It would be 15 over 1 and they would cross cancel, but then I have to multiply this by 15 too. M equals 450. Always think inverse operate. Are you questioning 450 divided by 15? Did I multiply wrong? Oh,
No.
I did. No, I didn't.
No, you're right.
Right?
You're right.
Huh?
I don't understand how you got
I multiplied 30 times 15.
Oh, yes, we're.
You want me to actually do it slowly? Okay, I've been wrong. Times 30 is 15. Look, if I divide by 15, I'm going to get my 30 I started with. Now, the last thing I want to leave you with is this, and I want you to overemphasize this because one thing I have to say 1,000 times and 1,000 times to people is this. Write down this equation. 2/3 x equals 18. This will be a huge gasper for you.
Not yet, not yet.
He's always trying to steal the whole thing. All right, what type of equation is this? Add, subtract, multiply, or divide.
Multiply.
It's a multiplying. So to solve it, I have to divide by 2/3. Well, if you go back to the weighing machine back there, when you divide by a fraction, that's the same as Chase. Yeah, I could do this. I could do this and write divided by 2/3 here, but when you do 2/3 divided by 2/3, when we divide by fractions, what do? You flip and multiply. So rather than writing it down as divide by 2/3 and then do all that, here is what I will tell you. Anytime you have a fraction in front of a letter, flip and multiply both sides by that fraction, because that's what division is. By a fraction, you flip and multiply. Yeah. Oh.
Pressure here, pressure.
Shake it up, baby, now.
Shake it up, baby. You sound like a dripping flower. You sound like.
Because what happens here on this? The 3's cross off, the 2's cross off, you're left with just the x, and then over here you just make this a fraction. A little cross canceling here, 2 goes into 2 ones, and then the 18, 9 times 3 is 27. 2/3 times 27 will give you 18. Again, when you see a fraction in front of the letter and you solve an equation, just flip and multiply. It's just a quicker way to getting to where you need to go without doing, oh, I need to divide by 2/3, which is flipping and multiplying. That was somewhat. Let me see what else they have for us here. And don't be afraid if they give you decimals, because it's all the same thing. You know, x minus 1.2 equals 3.6. What am I going to do to solve that? Opposite of subtraction is the inverse. You add 1.2 because that gets rid of this. You add 1.2 and your answer is 4.8. That's what x is. X has been isolated. I like 4.8. It really uncomplicates the whole thing. What about if it's a fraction? X plus 1/2 equals 3/4. How do I get rid of this plusing 1/2? I subtract 1/2. Think of the opposite. Change the common denominators. 3/4 minus 2/4 is 1/4. How many of you knew it was 1/4 before I even did that? Anybody? Nope. Not at all. All right. With that being said,